Okay, so today we're doing a deep dive into Popocatépetl. We've got this volcanic activity report you shared.
Right, it's pretty fresh data.
And the idea is to, unpack what it's really telling us about what's happening under the surface there.
Exactly. It combines what people saw with what the instruments picked up. A nice full picture, potentially.
So starting with the visual stuff, the report mentions yesterday was actually quite cloudy.
Yeah, initially obscured, couldn't see much at first.
But then it cleared up and they saw constant smoking.
Constant emissions, yes. And then overnight, something interesting, incandescence.
That reddish glow around the crater.
That's the one.
Right.
Suggests, pretty hot material right near the top.
And then today, the report says visibility was much better.
Much better. And they actually witnessed an eruption during twilight.
Wow. So visible eruption. It's a good reminder it's, well, very much active.
Definitely brings home the energy involved.
Okay, so that's what we could see. But the real deep dive, as you said, is linking that to what the instruments detected underground during that same 24-hour window.
Precisely. Because the visuals are just part of the story. The seismic gear tells us about the inner workings.
Right. So first up, the report lists 54 low-intensity exhalations.
Okay, relatively small puffs, mostly water vapor, volcanic gases.
Standard procedure for Popo, kind of. Just letting off steam.
Sort of confirms it's actively degassing, which is normal. But then there's more significant seismic stuff,
Like what?
like 178 minutes of low-amplitude tremor.
178 minutes. That sounds like a lot. What exactly is tremor telling us? How's it different from just like an earthquake shake?
Good question. Tremor, especially this low-amplitude continuous kind, it's generally the signature of fluids moving underground.
Fluids. You mean magma.
Magma, yeah, or maybe volcanic gases moving through the conduits under pressure. It's like you can almost hear the plumbing rumbling.
Okay, so tremor equals the volcano's internal engine working, magma on the move. But then there's this other thing flagged in the report. 57 instances of high-frequency seismic activity.
Right, that's different.
How so? What causes that high-frequency type?
Well, while tremor is more like fluid flow, these high-frequency events, they're usually linked to rock breaking, brittle failure.
Rocks actually cracking.
Exactly, the solid rock fracturing under stress. Near a volcano, this could be the ground adjusting to the magma pressure, or it could be related to regional tectonic stresses, the bigger plates shifting around.
Okay. So putting it together, we see the gas and occasional bursts on top, but underneath the report shows signals that suggest magma is moving and the rock itself is cracking or shifting.
Yes, and that combination is what's really interesting here. It's not just volcanic activity in isolation.
You mean it's showing the volcano interacting with its surroundings?
Precisely. You've got the internal volcanic dynamics, that's the magma causing tremor, and you've potentially got external tectonic forces involved, causing those high-frequency shakes. They seem to be happening together.
So the volcano isn't just doing its own thing, it's tied into the bigger geological picture of the area.
That's what this specific combination suggests.
Yeah.
It points to a really complex interplay.
It definitely paints a more intricate picture than just seeing smoke. You've got these two powerful forces, the magma pushing up from inside and the Earth's crust maybe straining from the outside.
Right. And seeing signals for both happening basically concurrently within the same 24-hour report from Popocatépetl. It implies this is a zone where those volcanic and the regional geological processes are really closely linked.
So for you listening, when you hear about activity at Popo, it's worth remembering it's not just one thing.
Exactly. Look beyond the smoke plumes.
Yeah, you have to consider these different underground signals, the tremor telling you about the magma, and these high-frequency events telling you about the rock stress.
It's about appreciating all the different processes happening, almost in real time.
Absolutely. Which brings us to a final thought, really stemming from this report. If we're seeing signs of both magma movement and tectonic-style rock fracturing happening at the same time under Popocatépetl, what might that imply about how volcanic eruptions and maybe even local earthquakes could trigger or influence each other in such a complex spot?
That's the million-dollar question, isn't it? How intertwined are they, really?
Definitely something to think about.